thank you very much for attending our presentation and for being here in time, despite the fact that we don't have breaks between the sessions. I hope we...
And it's before the lunch.
And it's before the lunch, yeah. So maybe some of you want to take a break. Thank you very much for attending our talk. Ionuț and I, we thought about talking about something different than AI today. And I hope that you will enjoy that, because I think the other 99% of the talks have at least once the AI. Should we include that? Too late. Okay, I'll skip over my presentation quickly. If some of you already know me, it's most likely because of my YouTube channel or one of my books. And I do invite you to follow me on social media, especially for discussing more subjects after the conference today. And we have Ionuț here.
Yes, I'm not writing books, but I have a website. So if you want more details about myself, you can just type in ionuțbaloșin.com, and there are constantly publish articles. And I do a bunch of things as written on the slide.
Actually, Ionuț, he's one of the recognized architects, I think, in Europe, I can say, if not
in Europe,
the world,
at least.
Thank you. So you really find a lot of interesting articles, especially on performance, no? But today we talk about security, so it's a different subject. This is a book I collaborate on with one of my friends, Adib, who started working on the book a couple of years ago, and I've decided to answer his call and help him with finishing the book. And today, a part of the presentation is also inspired from this book, especially some of the diagrams that you will see. If you want to find out more about the things that we're going to talk about today, I invite you to take this book. It's already early access available. And we are only discussing about a very small part today of what security really is. However, security, especially today, is a very important topic. And I constantly hear about situations on different levels where people manage to break organizations and enterprises. I think the whole part from the mathematics to the hacking on the timeline that you can see is important. We are going only to discuss about Java today and about the application level, but 4 points that I believe to be very important, and you should at least be aware of them if you are developers and not only. So, Ionuț, maybe you can tell us what these are actually here.
Yes, so the way how we structure the talk, it's based on these 4 principles. I hope they are mostly well known to you.
Who knows them?
Who knows all of them? Nobody. Okay, so then this is your talk. Good, so let's kick it off with the first one. And second point is we try to schedule it starting from real use cases. So each of these is backed by a real use case, because this is the way how we resonate easily from practice to theory, and of course going down into the code. And the first use case, maybe think of it, because I'm going to ask you to which one of those 4 principles it relates. In general, it's about, for example, you have a company and a client, or 2 parties, and they want to send files. And the question is, I want the transfer itself to make sure it's not faulty. So on the other side, once the file has received, I want to make sure it does not contain malform, so it's the way that the sender sent it. To which of those principles it relates? I can also...
Who knows?
Perfect. Perfect. So now let's zoom a bit into what integrity and how we can do it. There are a bunch of options on integrity. When I say a bunch of options, there are third-party libraries. Uh, multitasking sometimes doesn't work unless it's synchronized, so yes. There are a bunch of third parties that we might use. Have you ever heard about all of this? At least one, maybe? No, it's very good. It's okay because we won't talk about them today. It's just for the slide, yeah? But what we will talk, because we are Java developers, we talk about our JDK APIs. So you have on the right side the image with the lady, and we will be focused on the JDK side.
So you are her here.
Yeah. Yeah, sorry, not you. Good. Just before to zoom in a bit, this is briefly explaining the architecture, what are for the security providers in JDK. Honestly, you don't have to care much about it. More specifically, the JCA part and the JCE part. In the former versions of the JDK, they were kind of split. Now there is no difference. I mean, you don't see it. Yeah? It's the same package. What you can influence at the code level is if you want to change the provider, yeah, bottom line. Do you know what's the default provider in JDK? Very good, yes. So the Sun JC is the default one. But of course, you can exchange it. You can use Bouncy Castle if you want. Why or when would you do that? The Bouncy Castle adds other more, it's a bit more comprehensive, maybe a bit fast on some algorithms, offers you more options. But now it's also depending on your use case. Yeah? If you don't need it, stick to Sun, but also keep in mind that you can change them, yeah, to benefit of a broader set of options. And when we talk about integrity, integrity refers to the fact that I want to guarantee that my content, it doesn't matter it's being a file or whatever, it's not malformed or changed on the receiver side. And how we can do this? One option is with these hash functions. Have you ever seen a hash function? Yes.
Who's using this on a daily basis? Every one of you should have their hands up because we are using it on a daily basis, I'm pretty sure. Can you explain us why?
Yes. The thing is, it's everywhere on the internet. Think of when you download a package over the internet. When you download a package, there is a short checksum. It's probably, and that checksum, it's actually the result of the hash function being applied. And in these hash functions, it's irreversible. Yeah? So you apply it once and you get it. But I would like to show you an example for Maven, actually. So this is, as you see here, it's a Maven repository. These are the Spring framework. And as you see here, you can take the jar, but also they're like this hash SHA and MD5. Yeah? So this is here. To make it a bit more challenging, do you know what is not quite good with those? I'm referring to MD5 and SHA-1.
Correct.
Yes.
But more general said, we shouldn't use them. So I think my first question, actually, the previous question could have been, do you ever use Maven or Gradle? Then you use this kind of stuff. And second is, I think, MD5 and SHA-1 should be dead. Okay, but we are still using them.
Yeah. I think they are dead. They are deprecated in the standard. They are still using here, used here for probably historical reasons and the fact that it's not a big security threat. But if you do something for yourself, stop doing this. MD5 and SHA-1, they are not it's not the way to go. But now the question is what you can do it, yeah? And therefore, I will show you an example how to do nowadays this hashing, not the way that the Maven repository hosts their artifacts using SHA-1 and MD5. And this is using another algorithm, which is, I have to zoom a bit. Is it good enough? Yeah. If you see here, it's SHA-256. So this is...
Make it a bit larger.
A bit larger, yeah.
Back of the room, yeah.
Yeah, so this is actually what is recommended today. So this is SHA-256. Don't use SHA-1, don't use MD5. They are deprecated. And how you do it, it's pretty simple. Yeah, how you encrypt your data, you just apply, so actually you have a byte array, and then you generate this digest, and based on the JDK API, you create the hashing.
And if you want to know why did we choose SHA-256, next week I'm in Brasov, and I will explain that. You can come there, okay?
Yeah. So this is one key to consider. So the lesson learned here is always, if you need something, especially in the security, check what is not at least deprecated. Yeah, to not use deprecated stuff. Next thing is another use case. Have you ever encountered a situation where you had, for example, to store some sensitive data on your site, like, for example, passwords, whatever, yeah? How did you store it? Did you use what they call encryption at rest, which is, for example, on a cloud provider, it's you just tick something and it's there, or you did it programmatically? If you did it programmatically, how did you do it? It's about the same idea. It's about, sorry? Yes, it might be, but it's not where I want to go.
It's not really confidentiality, because you cannot revert the hash function. So it's actually, should we?
Yes. The thing is, if you store these passwords in plain text, that's of course not an option. But you can hash those functions with some algorithms. And those algorithms, for example, there are some recommended algorithms that actually, when you store them, you store only the hash. And then when, for example, the user types in the password, you compute the hash and compare with the hash from the database. The question is, how do I make sure that the hash, there are no collisions, right? Because that's the problem. And this is what I would like to show you today, yeah? How to make sure what you have to use to have less collisions or no collisions at all.
Which we can call privacy, if you want, as a different point out of the four we had, just to not call it confidentiality, since we don't discuss about sending data that is, available for someone else. Because the password should be just for you, no?
Yes, yes. So here it's one option. How can you do it? So it's again about hashing, but this time you don't have to use SHA-256, but then you have to use, for example, something else, which is called Argon second. By the way, this Argon second, do you know which security provider offers it? It's what security providers we discussed initially, Sun and Bouncy Castle. Yeah? Do you know who provides this one? If you don't know, that's not a problem. You can take, for example, the import, and it's a Bouncy Castle package. And the way how you can do this, for example, you have a secret, and when you hash the secret, to minimize, to ensure the uniqueness across the hashed output, it's recommended to use a salt. A salt, you can generate a salt. How you can generate it, it's a random byte array. And then you tell to the algorithm itself to use a salt, and usually the algorithm also, it's better to use multiple iterations. And these two, the salt and the number of iterations, make this uniqueness of the passwords. So this is the way how you store the hash, or how you can take the password, hash it and store the hash in your database, minimizing the collisions. Yeah.
Yeah. So mathematically speaking, if you have a hash function, you transform the input into an output and you cannot transform the output back into an input. The problem is that if you have the same input and you generate the same output every time, so you have an algorithm without a salt, meaning that you have this input and every time you hash, you get the same output. What you create is, what you can create is then a rainbow table when you can query reversibly. So you query on the output and you find the input. And that's also something that you avoid using algorithms like this, like Ergon, bcrypt, ccrypt, scrypt, and so on.
Good. So that was the use case with the password hashing. And now we are landing on the next use case.
Use case 3. So we talk about here a little bit more than integrity and a little bit more about just transforming our data into something. And can you guess which is the point out of 4 from the beginning of the presentation that this refers to? So it can be integrity, authentication, confidentiality, or non-repudiation. These were the 4.
Can I also try?
Yeah, you can.
Maybe the second one.
Wow, surprise. Okay, now you know the answer for the next one, no? So authentication comes with a little bit more than just integrity. Now, if you have a hash function, regardless if it's a weak one like MD5 or SHA, or you have a stronger algorithm like the one Ionuț presented earlier to, for example, encrypt passwords and store them at rest, you don't have a way in which you can guarantee that someone who knows the same algorithm didn't reapply the function, no? So imagine like with the Maven case, now you download the file and you can use in that case the pre-computed SHA to verify that what you have downloaded is the same, but you cannot guarantee that both of them haven't been changed. Because someone in the middle can just interfere, make a change, and then you still get what looks like is good, but is not good in the end. To solve that, you can have kind of a password, you know? And the most generic way to put it is with a message authentication code, which is something that you compute based on the message, but it relies on a password. Now, I will not bother you with the code, but one of the places where the MAC is used a lot and where you are actually using it, again, I can say you are using it on a daily basis, is what comes from a package of standards called Jose, and I'm pretty sure maybe you don't know what Jose is, or maybe you've heard about it. Even if you've heard it or not about the standards, it's more likely that you've heard about JWT, because it's something that we use today for authentication quite a lot, integrated in multiple authentication standards, including the OpenID Connect and, of course, the OAuth2 standard. So that's the signature there, and you can see it's a MAC. I mean, if you can make it a little bit bigger, that's a MAC on SHA 256 that is actually computed as a signature based on the data. And that is basically the signature of a JWT, which guarantees that if you change something in the header or the payload, which represent the data transferred, it will not be the same anymore. And if someone interferes, if they don't have the private key in this case, or what we can call the simplest the password, then they cannot just interfere and change the signature, which ensures you more than just integrity, it ensures you authentication. So that's the second point. Both integrity and authentication can be implemented with the JDK itself. Sometimes we need to add a security provider to enhance our capabilities, such as Bouncy Castle, but I promise you all of the points that we present today, they are implementable solely with the JDK, which is great. Can we go back to the presentation? Okay. And since you have seen already the example, I'm gonna skip over that. And this is a recap. So now we discussed SHA2, SHA3, and HMAC all of them can be used for integrity. Only MAC out of these 3 present in the table can be used for authentication purposes. Do not use SHA-1, that's why it's not in the table. Okay, we discussed about this. You are using it daily because you use Maven and Gradle, but don't use it with any other. Yeah. And then, can you guess without reading what this is about?
But maybe here it's a trick.
But maybe here it's a trick. No? Confidentiality. No? Everyone guessed. So, for confidentiality, we need encryption. We want to send some information or to store it, but to make it available for someone else. We have 2 options. We can have a password, but we will call it a key. And we use that key to change cryptographically, to digest the information in such a way in which you can use the same key to get it back. It's very simple. It's like you put it in a locker, no, in a safe. You put it there, you have a key, you have the same key to take it out of there. It has some advantages, it also has some disadvantages. We have multiple options that we can use here to implement that, algorithms such as RSA or ECC, which are probably some of the most used. They are all of them provided directly by the JDK, and they are enhanced by security providers such as Bouncy Castle. And the other alternative is using asymmetric. Oh, sorry, I was discussing about the symmetric key, and then I saw the slide. So the symmetric key was the one with the locker. Now the asymmetric key is the one where we have a private key to encrypt, a public key to encrypt, but then a private key to decrypt. So meaning only who has the private key, only those who have the private key can decrypt the information. As I was saying, both of the approaches have advantages and disadvantages. So when do we use the symmetric key encryption? When do we use the asymmetric key encryption? So it's very, it's more performant and easier to use symmetric key encryption when you have to do anything that doesn't require a key exchange. So if you can keep the key secret, because that's basically the most important thing, then I would recommend you use symmetric key, but that means the key should go nowhere, should basically not be shared with anything. So if you simply want to have a system and do some encrypting these partitions, then using symmetric key will provide you with more performance. If you have to share the key, then it's not really wise to use symmetric keys, because remember, the key is only one, which is the private one, being able to both encrypt but also decrypt, and you don't want to lose it. Sharing it means more probability to lose it, so you don't want to be in that situation. The asymmetric key encryption system offers you a public key that you can basically do whatever you want with it. You can make it public, because that's why it's called a public key. Everyone having the public key can encrypt, but only who's privileged enough to have the private key can decrypt. So situations like, for example, authentication using hardware keys. Do you know how that's working? No, you have like a stick or something, you put it into your USB, and automatically your operating system logs in, or your application logs in. How does that work? You register it in advance, you put the public key in whatever you want to use it for authentication, for example, your operating system or that website you want to authenticate with the hardware key, and then the hardware key, only it has the private key. So then a start of message exchanges happens, and only if you have the private key, you will be able to decrypt the message. So only if you have that real key, hardware key, and plug it into your USB, and you have the private key that can decrypt the message, you will be able to authenticate. It's like putting your username and password, but instead of putting your username and password, instead of proving you are who you are with a password, you just have to have that private key, which will be able to decrypt that message coming from the operating system or website or whatever application you are trying to log into, for example. In that case, it's very important to have an asymmetric key pair to make sure that there is only one device in this case that has that private key stored, and only the public key is shared No, because you have to share it somehow. If you would share the private key, then someone could intercept it and then can authenticate for you. Of course, this was only one example. There are a lot of many places where we use the public-private key encryption, but I wanted to make it a little bit more.
By the way, question: where do you store your keys?
You mean the private ones? Because the
Yes,
public ones you
yes.
cannot
Yeah,
you can
the
throw
private
them away.
ones.
No.
Java key store. Yeah. Okay. Yeah. In practice, yes.
So in a design application, a vault or something that ensures you security of management for those private keys. This is the only way in which you should store them. And I think we have a slide about that later as well. No.
We will talk about that. Yeah. Do you want to see some code or just words listening? We have also code for you.
I think we can skip over the code since we have a short time, but we will deliver your presentation afterwards. So you have the links. These are all links. You can just click them, and you will see the implemented stuff in Ionuț's repository.
You can also start it.
And this is a recap again. So we discussed about integrity, authentication, confidentiality, and is the next one non-repudiation? I don't know. Let's see, Ionuț, maybe.
Yes, this is, imagine a use case. We all work with secrets. Yeah, secrets to connect to an identity provider, secrets to connect to a database, whatever. So we play around with secrets. But when we write code, yeah, we can store those secrets next to the code, because this is how we do it. Yeah, we keep those username and passwords in the code. I have an example for you, like here, maybe. Nope, this is. Where is the? Yes, here. So look, what I'm telling you is, let's suppose you have an identity provider, it doesn't matter the name, and then you have a secret, yeah? You can store it in plain text and version it. Is it a good practice? No?
Anyway, by the way, this looks like it's encrypted, no? It looks like it's encrypted. It isn't, no? What it looks like, that one? It's a... Okay, so it's just encoded. It's just encoded, which means if you know the algorithm, you can get it back. So make sure you don't rely on something like that, because that doesn't have a secret behind the scenes. So it's not confidentiality. That is only a way of changing it in a different shape, so it makes it easier to transfer the bytes as a string or store them. But it only offers the commodity of storing and sending the data. It doesn't protect it anyhow.
Yes. So don't do like I did here. Yeah. But what you can do, and what I'm also doing, I'll try to explain a bit. So when you have any type of secret, you have to encrypt the secret first. And on top of that, you have to encode the secret, base 64 encoding. And then you have to store the result in the property of the file. But now the question is, how can you decode it and decrypt it for that particular environment? Because in a real use case, you have to deploy your application across multiple environments. And ideally, each environment should have a different secret. You can do in test one, for dev, SIT, UAT, but production should have a different one. And the logic behind is you can store all of those secrets, encode it and encrypt it, but during the CI/CD pipeline, you can use the vault that we talked before, decode the secret and inject it, decode it on the environment itself. Yeah, then this should be implemented on the infrastructure levels. Therefore, you don't care. Of course, it's a bit more difficult for you as a developer, because if you start something locally, it might not work, and so on and so forth. But it's the way how you should do it. Yeah. So protect your secrets, encrypt them, and during the CI/CD pipeline, decrypt it. And once the application is deployed on that environment, it has the properties already fed in. And you can do, for example, here you can have properties for each environment. This is how I do it, because usually they are different. Are you, do you do this? Yeah. Good. Yes, exactly.
And there are a lot of options for this. No, it depends on how much money you want to pay for it. You just chose the Lamborghini, but we have even cheaper options than AWS.
To start the secrets.
Okay.
Yeah. Okay, so this was one takeaway. So keep it safe.
And I think this is the last use case. I think we should go quick over it because we don't have so much time left now. But since this is the last use case and we didn't talk about non-repudiation, this should be non-repudiation, no? So when you want to make sure that the transfer, the data is verifiable, meaning that you know exactly who made a given operation, then you need signatures for that. And again, the JDK offers you that. So non-repudiation is based on cryptographic signature, which is usually done through asymmetric keys as well. But in this case, the keys are reversed. So you have to have the private key for the active operation, for the signing, and then whoever has the public key can verify your signature. This way, you store the private key to only whom should be able to sign that data, and then you can just share the other key to whoever wants to verify it. We need certificates and digital signatures because we want to make sure in many cases, even between applications, that the communication is verifiable. Now, especially when today, when we have so many distributed systems and even in geographically regionally distributed systems, so the communication runs throughout the internet, which means that someone can just jump in between very easily and change the data in a way or another throughout the communication. So I will skip over this because you have it in the repo, and I think that was it with one exception. I will give you a book, but it cost you a really difficult answer.
Some money, of course.
A difficult answer. And some money, but I have them with, I have some other books, so if you are not lucky enough and you want one, you can just come at the reception and for a small amount you will be able to get one with signature. Okay, joking aside, this is the book for you, but you have to be the first to tell me what Vox Day Bucharest edition is this? 8, who said 8?
8 ones, yeah.
You said 8. It's yours.
Yeah. Very good.
Thank you. So you have the sources as well on Ionuț GitHub repository, and visit also his site and his material for more than just security, especially for the performance stuff. I really love it. And of course, I do encourage you to follow me on social media and give me the feedback for the books as well. And with that being said, Ionuț and I, thank you very much for attending.